So welcome to Module 5 Lifetime Data Analysis Cases. So after to have an introduction about the lifetime data analysis methodology and all the statistical mathematics concept behind lifetime data analysis methodology, now we had a chance to see in practice how we apply lifetime data analysis. So you're going to see that many of issues and questions that probably you had, and also the concerns to understand and to apply lifetime data analysis, you can see that by using a software solution that will be very simple. But even though it's very important to understand the concept behind the lifetime data analysis. So our case study 1 will be the Pantograph. So the Pantograph have different parts, and one of the most sensible one is these parts in here, and this one we'll discuss in our example. So we have already spoken about the prediction by using the plot method. So that's the picture that we presented before, the same picture I have in my book, and you can check in there and get all the details about the case, but it will be enough if you look on this example. So we have the 10 carbon strips from 10 pantograph in different trains. So we have a fleet with 10 trains, each train have one pantograph, and then now we are collecting data from the carbon strips. So that's we discussed before, is a grouped data. So we got the data from a sample of a population of equipment, so that's the carbon strip in different trains. Okay, and then of course we capture the first failures that happen and each interval, and then we want to predict the reliability, the failure rates, and as well as to check which PDF better fits in such data. We can also do that in concerning the times in hours or even in kilometers. Okay, and then by applying the Bernard equation, we had a chance to see that we have order of failures, and then we have, by applying the Bernard equation, we have this probability of failures. So the first step after collecting data is to paste the data in a software, so you can have here failures in time. So we have the failures in that related to each carbon strip in each train that we collect in here. So after doing that, we needed to define which are the best PDF that fits such data. But before that, of course, I need to select the model here. I just select the regression model in X to carry out and make the assessment of which are the best PDF that fits in such data, as well as measure ranking for the plots, for the reliability plots and the viable PDF. So since I defined the regression methods to define my PDF, so all this calculation that was presented in the previous model will not be necessary. So here we can already see that we have all the possible PDF that we have in this software, the viable software from Reliabiltiy. And then when we click on analyze, the software by itself carry out the rank regression assessment and predict the coefficients correlation and compare all of such coefficients correlation for each one of such equation, and based on it the software puts the rank, the one that have the highest value to the one that have the lowest value. So when you click analyze, so that is the result. The software demonstrates that the viable 3 parameters is the one that have the highest rank. Here we can see that's the information that they give about that. That's the panel on the left shows the rank for the distribution that were considered. Rank 1 is the best fit for the data. So we have a rank 1, we can we choose rank 2 in this case just to demonstrate what we did previously, to prove that the calculation that we did mathematically is also the same results that we've got in the software. Okay, but we can use also the viable 3 parameters. So let's take a look on the result that we've got. So here, since we click on the assessment, and then we got our parameters, so beta and eta. So exactly the parameters that we've got when we discussion about rank regression assessment, and that's the example that was carried out in there. So we've got the same parameters and you can see that the coefficient of correlation, this whole value, is very high. It's almost 0.992 is almost 1. So that shows that the Viability parameter has also high correlation that can be used to represent this failure data. Okay, so based on it, since the software selects which PDF is better represented and by such data, you can choose the second one in Hank. So here you have the option of all PDF. You can choose by yourself, but it's always recommended to carry out the test, and then the software will give you the whole value, the coefficient correlation value, as well as the parameters of the PDF. And based on such parameters, the software will plot automatically the functions. So here we can see the plot based on the Viable paper that is calculated based on the ranking method. So if we've got 63% of here, we've got the eta value, and of course the angular value here. If you look on the paper, you get the beta value. It's another method that we can apply. So just to demonstrate that in this software we can also carry out this analysis. So when you look on the Viable parameters, so depends here. Let's just coming back here. You see that the beta value is very high. It's higher than 2.5. So in this case, we have something similar to a normal distribution. Remember that the Viable is a generical PDF, and because of that, in this case, that will represent a normal PDF when the value is between 2.5 and 4. And then as higher as this beta value gets, it's starting to become closer to a Gumbo PDF. And we always have a chance when you have a software to plot it. And here you see that's a normal PDF. We have, despite to have the shape of normal PDF, all characteristics, the parameters is from the Viable. But you can see that the failures range between 2.3 months and 1 month as a standard deviation. Okay, so as well as you plot as the PDF, automatically we can suggest to have the plot of the reliability function. So we can see the reliability in 2 months is very high, after 2 months time to decrease. So 2 months would be the good time to make some intervention. So here we can confirm that when we plot the PDF failure rates in a software. Before 2 years here, we are also be able to anticipate the failures after have the increasing failure rates. So let's take a look on the software now. How does it work? How to go through this example step by step. So here we go. We already open the software. So just to have an introduction how to open a standard folio. So we click on it. That's the starting point. So there is a request about the type of data. In our case, we work in time to failure, and we choose months as a parameter. And then that's why we discussed before the type of data that we have in our database. Is right. If we have the right sensor data, we choose this one. If we have interval or left sensor data, we choose this option. And if you have grouped data that are, in this case, are equivalent, a number of equivalent that failure in the same date, or even in the same interval of time, we choose that. If we have not, we just click in time to failure. That is a complete database. Okay, and then that will come this template here already with months that we can go for. So let's put here the name. Let's rename here. Let's put case 1 exercise. That will be great. Okay, so now of course we need to copy all this search information that we've got from here. Okay, we need to copy such information that we've got from here. That's come from our database. And then if you have this data in Excel or in Word files, you can paste copy and paste such information. So here we are copy and paste our information, so we can put the name of our database here. So that is about Pantograph carbon strip. So here we just put it in data 1. Okay, so we already have the choose of the ranking regression method here and the media rank here for assessment, but the most important thing is to put the ranking regression here, and then of course we want to check we want to carry out the goodness of fitness test. So that is the window that gives us the option to carry out such analysis. So that comes out this window. So based on it, we just click on here in analyze, and then we've got the same result that we had before. So you can see the ranking here. The best PDF is 3 parameter viable or 2 parameter viable. So if I want to choose 3 parameter viable, I just implement in here, and then automatically in this field that will be calculates the parameters for the viable 3 parameters. In our case, as we choose viable 3 parameters, also have a high coefficient of correlation. Here we can compare, that's the correlation coefficient for the viable 3 parameters is 0.996, and if you choose the viable here 2 parameters, you can see there are a lot of PDF options, and we can also get the same value, just a little bit smaller. 99, then the other was 996, this one is 992, so also high value. And then we've got the parameters for our PDF. So everything, you do not waste more than 5 minutes to do this analysis. And what I'm doing here, just explain that. That's why it takes longer. So since we have our PDFs parameters now, based on all the equation that we saw concern the viable 2 PDFs, you don't need to do this calculation. We just come in here and plot the PDF. So when you plot in here, automatically comes the probability viable paper. That's what I described before. So we can check when here is very interesting that we can check in which point we achieve this is 63% of the reliability. So just take a look on here. You click in these options, and then you can come here. You see all these values of the 2 axes below. You can see here. You see here that when I put my icon in here, below you can see these values changing. So just find the 63% of probability of failure. That will be the time, the value in X will be the time that's of eta. So that comes here. So around these values here, 3.7 is the value of my eta. So you can see here below the value of eta. Okay, so just a demonstration. Now of course beta will be the coefficient in here, but it's not necessary to have a paper in here because we have also the parameters already calculated. So we have these different options here to plot. The most important is the first one is the PDF. So the PDF demonstrates how the failure patterns happen, so that they are concentrated in between 1 and 5 months, around 1 and 5 months, 6 months, and we can see that's the pattern of the failure. So what's very important here, we can change the axis value here for, in this case, for 12 months. You have the carbon streak degradation every year in the beginning of 3 months, so you can change in here, and as well as up if you want to adjust your curve. So here we are, we have the PDF format. Now we add a new plot, so you click here in this option with the right button with your mouse, and then just insert plot. So now comes always to this probability viable function. I need to put here what I'm looking for, reliability. reliability plots, and then I just choose my reliability versus time function, then the reliability functions come out here. Okay, so we can see for different, and here we need to be careful that the values that is plotted here is in hours. I want in months, so I just click in months, and then the curve is automatically adjusted. Then we can see what's the reliability in 2 years. So in this curve here just show me that in 2 months the reliability is 93.8%. Is still high, but I need to do something to keep such reliability. Okay, so what's very important as well, the other function is the failure rate. So I will just include another plot here to demonstrate my failure rate, and then I have my file complete. So failure rate plots, so you can see the failure rate plot in here. So again, whenever you create a new plot, that's come automatically for the Bible paper, but I just need to move here. So I have another function, I have a reliability. I'm not interested in that, so I just put my failure rate, and then need to be careful here if it's represented properly. So I need to put in months, and then again put my 12 months. And then click in here again, and then the graphic is automatically updated. So we can see that let's just take a look in this graphic closer. So here we can see that in 2 months the failure rate is very low, but that is the point that I needed to starting to make some intervention in order to avoid the increasing failure rate time. So now I finished the case. I have all the main plots, failure rate, probability, and PDF based on the data that I've got and the parameters. So the next step in the run analysis is to get these 2 parameters and put in a table to have the organize the data for each equipment component in order to calculate the equipment failure modes. Okay, so let's go back to the case study 2 now, and discussion about the Balise. So the Balise is part of the ETCS system level 1. The Balise basically is installed in the railway, and then they get information. The information from the train go through the Balise. Then we have the line unit, electronic unit in here that gets information sent from the Balise to the train, and the information goes from the Balise to the line unit installed in here, and also go to such data center. So based on it, it's possible to firstly to get the location of the train, as well as to track some information, to send some information about the position of the train. So that's the ETCS level 1 system, and what we are talking about in this case is the measurement of such Balise components. Okay, so let's take a look that along the track in a specific region we have 10 Balise. So for each one of the Balise we've got the failures in years, and then we want to predict the PDF, define which are the best PDF that represent this data, as well as to predict the Balise reliability and availability. Okay, so let's take a look on what we expect to get from Balise. Since we have electronics and mechanical parts, you have the structural parts of Balise that can be degraded. So and then in this part you also can have some failures. Okay, and the electronics part you expect that you have random failures. So, and that's why it's very important to carry out lifetime data analysis. So similarly with the other case, we just get the data that we have in our database, in our Fracas system, and paste on the Bible software. Here we can see that we choose the failure units in years. So we put the 10 Balise, so it's a group of data. So we've got Balise, not only one, but a group of Balise in the same region, we need to be sure that they are operating in the same operation condition, and then we can get this sample to make assessment and predict the reliability performance of such service. So we assume in this case, for example, that this Balise came from the same vendor, so we are predicting the products of the vendor reliability, and we need to check if it's achieved the target. So that's one of the objectives. Another one is, of course, based on the PDF parameters, we can input such data in an RBD model. So the next step is, of course, choose which PDF best represents such data, and then when we choose the maximum likelihood methods, and based on likelihood methods, we got a gamble. So if you look on exponential, an exponential is the worst PDF to represent such failure data. And then, of course, by assumption, we expect, because we are carrying out assessment of some electronics components, we expect to have some exponential. But in fact, what we've got here was a gamble. And then, of course, and that's why it's very necessary to have a consistent and confidence fracas database, because in this case we can look on the root causes, that is defining the fracas, and understand why in this case we've got a gamble. We just go ahead with the gamble. We choose the gamble as the best PDF, so we have the mean and sigma in here. You can see you have the gamble, so the method was maximum likelihood, and we have the parameters here. So the maximum likelihood function here, you can see this value is you can see main analysis will be negative, and the idea is the PDF that best fits in this data have the highest value in this likelihood. So if you compare with another function, probably this value will be lower than this one. So and then after that you see we can plot all the gamble PDF, and then you see that real gamble shift to the left, to the right, and skew to the left. That's the shape of gamble PDF. So we see the reliability function. We have some failures in the beginning, before 1 year, and we can plot also the failure rate. So we need to find out why this electronic have this gamble PDF based on the fracas case, and if it's really effective, some actions to be carried out to avoid that such events happen. Okay, so usually in electronics we will not implement some preventive maintenance. We can implement some tests, but in this case maybe some issues related to mechanical or even the weather or external condition makes some of such Balise fails in a similar range of time after some time. So that can explain this reason for failures in such Balise. But we need to have a fracas to understand that, understand what we've got such value. Okay, so before to go through this case study, we just go to the software. Here we are. Let's shift to the Balise case. So yeah, that's what we've got similar. That is the Balise case that we've got to apply the maximum likelihood methods. We've got this parameter. Here you can see the PDF that we demonstrated during the presentation, the reliability function, and then of course we have here the failure rate. Let's do the exercise again. It's good to practice in order to have an understanding, clear understanding, and also to get used with some software solutions. And again, we open a new folio. So we choose this option here. We have completed data, so we don't need to choose such options. And then we click OK. They will open a new example in here. I need to waiting for that, and then comes the example. Is very important to change this time in month. The software always got the previous models that we have, so we can come in here and change for years. So here are the options. So just highlighting here that you have also kilometers and other different parameters. So in railway we can also apply in kilometers. Then of course we've got our data in here. Okay, so just put in here rename for case study 2. Let's put like the first one. Let's just fix in here case 2 exercise, and let's get the information that we've got in here in Balise database. Yep, now we have all the information that we need. We paste in here. We select the max likelihood method. So just a demonstration. Now we have that, and then we put here Balise. Okay, here we go. Now we choose the PDF that better fits in such data. So let's do our goodness of fitting test. Some seconds. So Gumbo is the PDF that best represents such data. We choose the Gumbo. So automatically the Gumbo value will come here, as well as the likelihood value functions. And based on it, I agree with the result, and then I start to plot the PDF. So I click on here to plot the first one. As I mentioned before, that is the Gumbo paper. So we want to plot the PDF. So here we are. The PDF is automatically plotted, and then I just put here to be constant PDF. Just change the name. If I click again, you see that and that's the Balise data. And now I click in here in the right button to have additional plot. And then what I want to choose now is the reliability plot. The reliability plot is here, similar that I presented. Need to be careful with the parameters. I will change by years. So that is the correct picture that we have. And now I just write in here reliability plot, and then I will add and click on the right button and add additional plot, that is the failure rate. It's good to create this additional plot because of course I can just have one plot and modify here. Here for example I created the failure rate, so since I have the reliability one creating here, let's put in years. I can just shift for other one, for example PDF, then the graph will be shifted here. But in order to have organizing data, I want to have one by one in here in my file, so it's easier. So this is the failure rate one. Just click on failure rate, that will come out in here in years. So that's perfect, similar that we've got in our example. So just some information, additional information that we have in the solution. We can make some calculation in this KCP tool here. Then of course we can calculate different parameters. For example, if I want to have the reliability in 1 year, I have this calculator, so they give me exactly the value. So then I can predict my performance index different times that I want to have it. Similar, if I want the mean life, they give me the mean time to the first failure, so in years, so that is the point, as well as the failure rate. The failure rate in 2 years is one value, so in 1 year is lower than it, and in 3 years you can see it's higher because of the increasing failure rate. So we have this calculator that gives you the benefit of predicts any different values that we have, and get some result automatically. You don't need to look inside each graph. Okay, so that was a case 2. Let's take a look on a case 3. Let's jump for our model. The case 3 is a brake. So now we are represents one equipment in a brake. When you see brake system, in reality we are represent this triple valve here. So how does it work? The brake, basically the driver brake have this valve in here. Depends on the position when they want to use the brake. They put in a position that's the compressor release the brake. So usually when the compressor are releasing the brake, when they put the position that they let the air come from the compressor into the main reservoir here, the pressure in this line is very high. So the pressure in if the pressure of this line is higher than the pressure that's come from the auxiliary reservoir, triple valve shifts to the left. And what's going to happen here? So the brake will come back to the standby position, and then the car can run and start and go ahead, move again. So by the other way around, if you stop the air in this position here, based on changing this position of the driver valve, so the pressure in this line will be lower than the pressure in the reservoir oil. So of course the valve goes to the other position, then this air will come from the auxiliary reservoir through the brake cylinder, and then make a pressure for in here, and then that will be the brake will be applied and will stop the bogie and the train. Okay, so in this case we are not assessing the whole brake system. Of course we assess the triple valve, and we can see in this example there are some triple valves, and that's different examples you see in here. That's what's happened is we had some 6-7 bogies, 30 actually are 30, 34, 36 bogies, and then in each 30 in each one of these bogies you have 2 wheels where the brake is applied. Okay, with 2 axles where the brake is applied. So in this case you have these numbers of the brake valves assessing here. So, and then as what I mentioned before, some of them are failed during the assessment time, and most of them did not fail. And then we put here the suspension concerning such data. So concerning all the fleets and all the bogies that have brakes, we now take into account the ones that did not fail. So that is the right sensor one. So then example of the right sensor. So what we have in here, after to define the template, we need to analyze, and then we've got the best PDF for this function is the 2-parameter exponential, and after the second one is log normal. We're going to use the log normal one because based on the Fracas system we saw that there are some design error in this triple valve that is well represented by the log normal. That's why the reason we choose the log normal. Also, the log normal has a high value of fitness for this type of data. So here are the data. Then by applying the log normal, we've got the parameter in here, and then we can carry on. We can see the PDF shape. We can see the reliability functions shape, many failures in the beginning, and the failure rate increasing after one time, and after that start to decrease. Okay, so before I finish this model, let's take a look on the software. So here we are in the case study 3. We have the number of failures in here, and you have 60 of the brake valves that did not fail, until 101,000 hours. Okay, so let's create this example to see how does it work. So we create as you follow. In this case, just to highlight, we need to we have not only complete data, we have right sensor data that are the 60, and of course we want to enter data group because 60 of such failures are all together. Okay, so and then we will be creating the template similar to this one. So that is here's the number in states. So we just copy and paste such data that we have in the previous one to make our life simple. In reality, you can have all such information in your fractals. As much as your fractal is organized, easier will be such lifetime data analysis. In reality, most of the time in lifetime data analysis is the data preparation. So you can see that since we have the data prepared to be input in a software, you not lose a lot of time on it. Okay, so we need to put the proper units. So here is in minutes, but we want in hours. In this case, that was assessed in hours. Okay, and let's put the name of this case as a case study 3. That's it. So let's put in here break valve data, and then we need to go through our steps. The first step is to choose the max likelihood method that we chosen before. Then we run our good enough fitness test and maximum likelihood, and based on maximum likelihood we will have the result of the rank of which PDF fits better such data. So based on this rank, of course, we can choose. In our case, since our fracas root cause demonstrating that more design failure, we will choose the PDF. So in the rankings, the second one is also very well ranked, so I need to click in here, come directly to the options of the functions and choose log normal. So since I choose the log normal, I need to click in here to calculate, so the software will automatically calculates the parameter of log normal PDF. Okay, so the next step will be I can come here and insert my plot. So I want to look on the PDF, this is the first one. Then I want to look on it, and I can see that most of failure happened in the beginning of life cycle, and then we have some failures that are happen later on. So I just want to put here PDF, and now I go ahead and create my other examples. So clicking again, right click on your mouse and create a new PDF that will be the reliability one. So similar that we saw, just as use this curve in here. I just put 2 to have a better picture. So let's just adjust that in here. So sometimes the figures need to be adjusted so you have a better picture of what you're looking at. Okay, so now that's great. You can see that you have no trends of failures along the time, and that is our reliability functions. Actually, it's not the PDF, so that's the reliability plot, and the PDF is this one. We have the most of failures are happening in the beginning, and this one is the reliability. Actually, it's written here reliability. So we have a lot of failures occurring, happening in the very beginning of life cycle, and then I will just put a new plot to have my failure rate. So I will describe it here: failure rate in hours, and then I choose the failure rate function. So I see that is starting to increase in the very beginning. After some action, it's starting to reduce. So that's my failure rate option. Okay, so let's go back to our final slide. So that was we look on this case, the break case study tree. We went through all this methodology. Here we assess the triple valve. We input the data in the software. After we carry out the goodness of fitness test, maximum likelihoods, PDF. We choose the log normal, and then we got the parameters. Then we start to plot the PDF, the reliability, and the failure rate functions. Okay, so that's we finish with this model. That's just to demonstrate how it's not too complicated to carry out lifetime data analysis. But of course, we need to understand all the mathematical and statistical concept behind the lifetime data analysis. I suggest that you go to Reliabiltiy website and get the manual of the software. This viable software has much more functions. We go through all the concepts in a lifetime data analysis training course that we have also online. And this training will enable to demonstrate different methodologies concerning lifetime data analysis, not only the basic one, but more information about lifetime data analysis. But the objective here was to give the introduction about lifetime data analysis, to give the basic information for enabling you to collect some data and predict choose the PDF and define the PDF parameters to input in your RBG. As well as if you need to carry out specific analysis for a specific one of the equipment, you can carry out similar analysis, and then you saw that you can plot your PDF, reliability, failure rate functions, and you can take some decision and get some conclusion about that. Okay, so if you have some question, just send me an email. That was my pleasure. So now let's move to the next model that will describe the RBG methodology.